Okay, pardon for it being sideways, but the other screen actually died. So my son brought it over so basically this is the LGMV times two completely isolated separate systems that are on the roof and in this one room. So you can see right now only one compressor is on, even though there's two heat recovery units on the roof and each heat recovery unit has two compressors in it. Only one is operating, satisfying the whole room. So the room right now is running at 77, 76 degrees. 6 air handlers, 3 air handlers for each system on the roof. There's 100 lights in there, 100 LED strip lights in there, going back 40 feet. So we're 27 feet across and 40 feet to the back with 100 lights. And the system is set up so even on the hottest day in the summer, it should not strain or be under any pressure, any not working hard. It's always working at its most energy efficient level. So right now they just have a mildly cool temperature of 77 degrees in there. They go all the way down to 60 degrees is their coldest they call for at the very end of the cycle, the last several days before harvesting. And at that time, for every degree you try to drop, you require more energy. And the lower the temperature you require, the energy starts multiplying. How many BTUs you need to remove and how much watts per hour you use increases. It's not linear, it goes up fast. So when they are trying to pull 60 degrees out of that and it's summertime and 70 or 80 degrees outside, you'll see all 4 compressors coming on, running constantly. And like my video in the last one you show, one compressor will get up and just as it's about to hit 100% usage on the one compressor, it'll shift half the load to the other compressor and you'll see it drop from 100 somewhere down 30, 40, 50, something like that. And it'll divide the workload up. And then if it stays like this long enough, it'll count off so many hours and then it'll switch the load to another compressor. And then as it keeps on working, it'll shut that one off, turn that one off, and then shut that one off and turn that. And what it'll do is it'll even out the hours so no component ever gets overstressed or overran. And this is why you don't use refrigerant gauges, because everything you could possibly see on a set of gauges is right here in front of you. And the pressures, where they put the pressure transducers, are where the pressure should be taken to get the correct pressures to determine whether or not, and the temperatures, whether or not it's low or over full or full with charge. Just like the new vehicles, like the video that I'm about to release later on this evening about the heat pump on the Audi that I worked on today. That is in the era where pressure gauges don't do you any good at all. Everything is off the manufacturer software. If you don't have the manufacturer software and you can't tie in the system, pressure gauges are not going to tell you anything other than a lie. Same going for trying to go by beer can cool. If you're grabbing the suction line on one of these units, you're going to think it's low and you're going to be pumping in refrigerant like somebody did on one of our other systems when they called in a refrigeration guy to come look at one of these systems. He's never touched a VFR system before. He's refrigeration. He's only done heavy mechanical piston type and stage systems, but he never did VFR. And he dumped in 27 pounds of refrigerant into one of the units and burnt up the compressor. And that's what happens when you have old time guys with old time thinking who have 30 or 40 years of experience. Means absolutely nothing anymore. That's it on this one. Catch you on the next one.